I'm going to speak in English today, but because it's not me, it's because we have very special guest, and we very honored, and we actually going to speak in English. The whole entire session going to be in English. I think a couple of people here will really be very good with that, especially the German speaking and non-Hebrew speakers. Yes, it's for you, special for you. So if you don't know me, my name is Jonathan. I'm doing a couple of stuff, running startup in Colgene in genetic field. I'm part of the Google Developer Expert Program that Ron will be happy to talk about that a little bit more. And actually, a big part of my life, I'm part of this amazing thing called Android Academy. We're more than 3,000 members. We're doing a lot of various stuff, and with the largest Android active community in the world. Not my word. Everything is actually because of you, because you're part of that. Of course, I'm not alone. There's a lot of people involved in that. So there is actually like three guys of us that doing all this hard work of preparing the logistics and all this shit. So it's Rafi. He's running. So Rafi, if you don't know, something that I'm really proud to announce, right? So Rafi just hired two developers from Android Academy recent course. And it's adding to all other mentors that hired, like Kobe, for example, and other two developers from a recent course. And we have a lot of such successful stories around that. So basically, you helping yourself to make this community much better in every day. And then we have also Yossi, that Yossi is also an Android developer by day and running Android Academy by night, right? So Yossi, couple words, something?
Yossi! Woo! It's a really exciting day for us, so enjoy.
And actually, this team is part of this amazing community. They're doing a lot of stuff. And as you know, who is here is the first timers, like first time in this place, and have no idea what doesn't going to happen here. Amazing. So for you, a couple words about us. We're doing a lot of things, everything around the Android and mobile. Our flagship course is actually a fundamentals where we're teaching everyone what is the Android, how you developing applications for Android, how you're doing good for the world by providing better apps. Also, we're running different courses like advanced course, like design course, when we combine Android developers with designers and create beautiful apps. We're doing the hackathon, we're doing the mentorship program that is actually the special program where we take the guys like you and take them to the next level, not just by learning Android, but also to guiding others. So, by the way, all the guys from the core team today is actually the one that were mentors before, and they just decided to step even more and work much harder than they do right now. And also, we're running advanced course. So this is actually the first meeting of the advanced course that will go to run for a couple months from now till September. So basically, every 3 weeks we're going to publish it really soon. Every 3 weeks we'll have advanced meetup in terms like about the CPU, memory, animations. Right? Very cool presentation about animations. Animations, networking, how they're doing network right, with all this like really advanced and under the hood stuff. And she's coming. So basically, we will skip to this part because she's a very special person that actually she was with us. So she came just on the spot because Eden representing everything that we believe in this community. So she started as a junior 4 years ago with a fundamentals course, and then she became a mentor, the one that actually paid back, actually coming and sleepless night at the hackathon, helping their team to achieve the greatness, to build a better app, to actually to push their boundaries further, and she's doing it almost 4 years. And as you know, she was a big part of us, so we decided to make it to cause her to work much harder than she's doing, and actually invite her to join our core team to work much harder. And now she's actually officially part of the Android Academy core team as well. So. So going back a couple slides, just two last things. So as you know, we're running an academy here in Israel, and we're a very large community. This summer, actually this spring, we launched an academy in Russia, in St. Petersburg, and in 1 week from now, we're actually going to have the final hackathon with over 60 developers that are going to build their app for the first time. Also, in beginning of July, we're going to launch an academy in Belarus. So why I'm telling you these things? So we really intend to launch it in more countries, actually to spread this amazing community over the world, and really to help others to provide the knowledge to others that don't have this access to the knowledge. So if you have friends living in another country and want to start this thing, amazing thing, and to lead it, you're more than welcome to contact us. We'll provide you all information, all materials, all exercise, every support, and we know, and you know how much support we're giving, that we can give, we will provide you, of course, for free, and everything we can do in order to make it happen. And the last thing, but very, very important. So, as I mentioned a couple times, Mentors program. It's not just the words. We really build this program, so it's like the second year in a row that we're running this program. We start like, last year it was about 10 mentors. This year it was 31 mentors. Amazing guys and girls that doing amazing job in order to take the developers to the next stage. And actually to really guide the teams. So I saw the mentors that sitting and guiding the whole teams of 5, 10 developers during the course, during the hackathon, how to build the app, how to achieve the greatness, how to actually to push the boundaries. And at the end of August, we're going to launch the new wave of the third wave of the mentors program. So if you want, this is your opportunity. Follow our Facebook room. We're going to publish call for mentors. Not call for peppers, call for mentors, and you're welcome to apply and to try yourself. And actually, it's not to try yourself. Actually, it will sound like this. If you want to help others and be part of this amazing community much more, this is your great opportunity. Do that, and you will have it at the end of August. We will notice you and we'll give you all support in order to grow and to become mentor, much better developer and much better team leader maybe, and we'll give you all skills to succeed in that. Am I bold enough to know about that? Woo! Cool. Today is actually, it's the special day, and this is the last slide that I'm going to talk. It's very special in a couple of reasons. First of all, we work on that really hard. I think the first time I contacted Florina, it was like 7 months ago, something like that. We really wanted this to happen. And finally, she's here. And I'm like, wow. I can't believe that this could happen, and I'm really proud to see how much, like, we did event with the mentors, and now we're doing, and I see smiles and hugs, and people finally meet with us, and you know, a lot of love spread in this room, right? So we're like lovely community. So you know, so you know the thing. So before Florina will step here and start to talk and give amazing her knowledge, I want to welcome her, and not just like only clapping, but we do the bar thing, right? But you know, this time. So let's start. So all of you know, for those that don't know, so there's the bar, right? Bar of the club. So here you start regularly clapping, like yeah, cool. And as much as I raise my hand, you're actually going loudly, going crazy. And you remember there is a G-Force, the security guys that's sitting a couple of words after that. I want them to come here to check what is happening here. What is actually happening? Right? So let's start. You ready?
Yeah.
Okay. I don't hear. Are you ready?
Yeah.
Let's start the clapping. Yeah, baby. Yeah.
Okay, let's start with the technical. Can everyone hear me? Yes. All good? Okay. One technical problem solved. Let's see if we solve the second.
Escape.
It's not my laptop.
Now we need to play.
Hi-ish, everyone. So what are we doing today? Well, multiple things. So first of all, I've been here for 3-4 days, and so far I've been very warmly welcomed. And everyone I talked to was very open and very communicative, and I want to keep this like this. So I want to make this as interactive as possible. So whenever you have questions, please ask me. Today we'll be focusing on, let's say, the architecture components that are already released, that are in 1.0. So lifecycle, live data, view models, room, and paging. And at the end we'll also do a paging code lab. But feel free to ask me at any time any questions. So I'll definitely make sure that we take some breaks between each of these sections. So I really want to hear from you. And to make sure that I hear from you, I do hope you like stickers, and I do hope you like the jetpack. So I don't have a lot of stickers, but everyone that asks a question, hopefully, will get a sticker. So make sure you're asking questions. Okay. Okay, so we're going to start with the life cycle, and we're going over what's up with the life cycle, what are the events, what are the states, what's the life cycle owner, what's the life cycle observer. So first of all, in the architecture components, we launched the concept of a life cycle. So more precisely, we have a series of events and a series of states that are corresponding to those events. So more precisely, you can see these as a sort of a graph where we have states and events. So we're going, for example, from initialized to created through the uncreated, so from one state to another through events. So we're getting events every time we're going from one state to another. And we also have on any event, in case we're just interested in something happened. We're going to go a bit more into detail and see when are these triggered and how and so on. Then we have the concept of lifecycle owner. So more precisely, a lifecycle owner exposes a method, getLifecycle, that allows us to get a reference to the lifecycle of that object. But more precisely, right now, we have only 4 components that have a lifecycle, so that are a lifecycle owner. The compat activity, the fragment, the process lifecycle owner, and a lifecycle service. So we're going to start with the compat activity and the fragment because they work pretty much the same. And then we're going to go through several use cases and see how exactly these events are triggered, when are they triggered, and then why you should care about them. So let's start with the use case when the activity is just started and finished. Because the activity and the fragment are pretty much the same, I'm just going to use the activity as an example. So when the application is started, then the app goes into initialized state. Then the onCreate method is called on the activity, and then afterwards the onCreate event is triggered, and then the application or the lifecycle moves in the created state. Then the onStart method is called from the activity, then the onStart event is triggered, and then the lifecycle goes into started state. On resume, we have the onResume event, the application moves in the resume state. But when back is pressed, well, things change a little bit here. Because first onPause is called and then started, and only afterwards the onPause method is called. Then we have onStop, and that moves to the created state, and then the onStop method is called, and then afterwards onDestroy and destroyed, and then onDestroy on the activity.
Not always.
So overall, you can see that these are, let's say, somehow mirrored. You can't see it here, maybe you can see it there. So you have created and then destroyed, or created and created, started and started. So things, I would say, might be quite easy to be remembered. But things might be interested when we are rotating the device. So when the device is rotated, Then the on-pause is triggered. And before the on-pause and the event, and then the lifecycle being in the started state. And then the on-saved instance state with the on-stop and the created state corresponding are triggered. And then the on-stop. That moves that triggers afterwards the on-destroy event, moving the application in the destroyed state, and then on-destroy. But what's important here to remember is that from there on, from on-saved instance state, the application has an immutable UI. So this means that whenever you're doing something here, well, it's... Okay, give me a second. So this means that whenever you're trying to modify the UI after the state is saved, well, it's likely to cause inconsistencies in the navigation state of your application. And actually, this is why the fragment manager throws an exception if the app runs a fragment transaction after the state is saved. So what should you do then? Well, if you want to work with the UI, you should check that at least the application or the lifecycle is in the started state. So this will make sure that you're in a state that won't cause any crashes in your application. Well, the fragment sounds similar, but it's a bit more complex because actually the fragment has two life cycles. The life cycle of the fragment itself, so the one returned by get lifecycle, but also the life cycle of the fragment's view, because the fragment has a view inside. So in the cases of attached or detached fragments, these life cycles can differ quite significantly. Let's continue. Okay. So.
Is there a way to mute them, maybe?
Sorry?
So they don't call?
Just the guy that joined, please mute yourself because you're sitting here.
Okay. Yeah, so what was I saying? In the case of attached or detached fragments, these life cycles can be quite different. So more precisely, the fragment's view life cycle can happen multiple times for a single fragment life cycle. So we are working on the view's lifecycle owner, and hopefully soon is going to be part of Jetpack. But we know things are complicated when we're working also with views. Then we also have a process lifecycle owner. So this is the class that provides the lifecycle for the whole application process. So I don't know about you, but I know that I implemented something similar several times in multiple projects that I was part of. So here's what's happening with the process lifecycle owner. So when the process starts, we no longer have that initialized event because, well, we don't have it. The process just starts. So this means that the first event we get is the onCreate. So then automatically the process goes in the created state. Then we have the onCreate method from the first activity. Afterwards, the same ones that we're kind of used to from the application lifecycle, from the activity lifecycle, sorry. So for onStart, we have onStart event, and then the started state, and then for onResume, the onResume event, and then the resumed state. But then the thing is that whenever you're adding other activities, well, nothing happens. So you won't get events whenever you're opening a new activity. But then, once you're adding it, nothing happens. But then once, for example, you're sending the application to background, when the onPause is called for the first activity, then the onPause event will be triggered, and then for the last activity that was open. The onPause event will be triggered, the process lifecycle owner or process lifecycle state will go to started, and then onStop with onStop event, and then the created state. So this means that if you're rotating the device, well, the onPause and onStop methods for configuration changes are ignored. So you won't get these kind of events if you're just rotating the device, but only when you're sending the application to background. Okay, once we're bringing the app again to foreground, the onStart and onResume are called, triggering the corresponding events. and then moving the lifecycle in corresponding states. Okay, but what if we start pressing back and because we want to exit the application? Once we get to the last activity, then the on pause, on stop will be triggered. But actually, the secret for all of this is, well, a timeout, a 700 milliseconds timeout. It's actually a delay with which you will get these events, and this delay is long enough to guarantee that the process lifecycle owner won't send any events if just activities are destroyed and recreated because of configuration changes. So in the end, this 700 milliseconds is the key for not supporting or not getting strange events. So overall, if you look at the process lifecycle, we get on create. When the process is created, we no longer get initialized. Then on start and on resume, depending on the first activity, on pause and on stop when the app is sent to background, on start and on resume when we're bringing the app again to foreground, and on pause and on stop when we're closing the app. So this means that from all the events that we have in our list,
Guys, help yourself if you're enjoying the hangout, please.
Okay, good. So it means that we're missing the initialized and the destroyed states. Because we don't need them, because our process doesn't have these kind of states. And then we also have a lifecycle service. So here things are also quite simple, and here we're again only using a smaller subset of the events. So more precisely, when we're creating a service, then we have the onCreate event. When we're binding, we consider that that's when the service starts. So that's when the onStart event is triggered. But the same when we're starting the service, or when onStart is called. So then we're considering that the service is in the started state. But then when the service is destroyed, then we're in the destroyed state. Okay, so how would you use these kind of lifecycle observers? Well, more precisely, maybe you would implement your own lifecycle observer, and then you would define what should happen in specific methods. So, for example, let's say that we want to start listening for location. Well, we would maybe define a start listening and a stop listening method, and then we would annotate these methods with on lifecycle event and the event that we're interested in. So just by annotating, under the hood under the hood architecture components will make sure that it generates all the code. So then it triggers exactly these methods when the specific events are triggered. If you're using, or if you're targeting Java 8, then I definitely recommend using a default, or implementing a default lifecycle observer. So here you would just implement the methods that you're interested in. So for example, instead of annotating your method with, what was it? On lifecycle event and on resume, you would just implement on resume, and then you would trigger what you want there. So the advantage of this here, it means that it's not using the annotation processor, so it means that you're skipping over that code generation part. And then, afterwards, all you need to do is, well, get the lifecycle either from an activity or a fragment, or from the process lifecycle owner, or from the service, and then add that observer. But what happens with the view? So I was talking about the view inside the fragment. Well, the thing is that in general, the lifecycle of a view, it's not that easy. If you're thinking only about a view that's part of a recycler view, it's more complex. So this is something that, well, we haven't worked on, or we were thinking of, but we haven't released anything. But what if you want to implement your own custom lifecycle? So someone, for example, was asking me, what if I'm implementing a library and I want to expose some methods so the users of my library have the concept of the lifecycle of my library. Well, you can just implement your own custom lifecycle. So we are giving you a set of enums, or the set of states and the set of events, and then you can just define what they represent for your use cases. As you've seen in stuff like the process lifecycle observer, or on the service case, we're only using a subset of them. So you can also implement your own custom lifecycle and then lifecycle owners. Before we're going to live data. So live data is such an object that respects the lifecycle. So more precisely, what's going on with it? Yeah.
About before you
Yeah,
move
sure,
on
sure.
to the live data,
Sure.
what, I'm trying to say, what is the big or supposed to be any big advantage of using the life cycle attitude compared to the simple callbacks that we used to have before?
So one of the main reasons why the lifecycle was, or the concept of lifecycle and lifecycle observer was created was because we saw that a lot of developers tend to put all of that logic in the activity. So you would end up with, let's say, logic that starts listening to location, all put inside the activity, because you would only want to start listening for location when a specific activity was open. So then you ended up with logic that couldn't really be unit tested, because you can't really JUnit test an activity. So that would be one example.
So I can just take the lifecycle observer and create tests.
Yeah, so yeah, you would move all of that logic from the activity. You would move it to a specific class whose role is just to control when these specific events need to be triggered. And yeah.
Will there be some test harness for these components? Did I hear you correctly?
No. So
that people will be able to JUnit test their component.
So in case you didn't hear the question was if there is any test harness for this. Well, let me go back here. So here, in the end, you're implementing a separate class, right? You're implementing your myObserver class. That's a lifecycle observer. Well, this class can be unit tested because it's not a fragment, it's not an activity, it's not a service, it's your own class that you're defining. So this means that here, I don't know, maybe you have some other components that you would use as a parameter in the constructor, but you can just unit test this class as you're unit testing any other class that you're creating. But before, since that logic of, let's say, start listening and stop listening was somewhere inside the onResume and onPause methods in the activity, well, you couldn't really test that. So in the end, there is nothing that we need to provide. It's something that you can just do. Because it's your class.
Because it's your class.
Ask a question?
It's Aishai.
Yeah. Yes, there was a question.
Why did you choose?
Is there a way to register process life cycles in manifest like A?
Sorry, I'll start with that. So if there's a way to register process lifecycle in the manifest?
In a way that will be not controlled by the programmer. It doesn't need to do it at any entry point of the application, but in a separate configuration file.
Oh, so you want something like a broadcast, like how the broadcast receiver works?
Yep.
Not that I know of. I could ask, but or I can actually. I should have taken notes. I promise I'm not reading, but I'm taking notes.
I will take it for you.
Yeah. Okay. Perfect. Because that's another reason why I'm here, because I want to get feedback from you and try to pass all of this information to, well, to me, make sure that I'm covering in case we're not, and then also to the engineering team in case we need to work on something. So, thank you, Jonathan.
How have you come to 700 milliseconds?
I thought about that too. So the question was how come it's 700 milliseconds? To be honest, I'm not really sure how they define it. I think it was a more Okay, this sounds good. But I don't know if there was a specific criteria or how exactly they measured. I'm pretty sure in the framework there is no magic number somewhere, so.
Last question and we will move on. Timo.
Right. How do lifecycle owner processor works with multi-windows? Because if a window is not focused, is it really in the background or not?
I haven't played around with multi-window, but in the end, if I remember correctly, it's all about the on pause and on resume, right? So this means that your lifecycle observer will still get the on pause and on resume callbacks whenever those are triggered. So it ends up being your responsibility of deciding what to do in those cases. So in the end, from what I know on when we have multiple windows, then other than using on pause and on resume, you can't really know. But I haven't used it, so.
I can answer.
Yeah, please.
So it's even with multiple windows, only one of them in resume state, another one in the pause state. So you will get the lifecycle method on pause callback once the user actually switching the window.
Yeah, so in the end, you're just using the on resume and on pause. There's nothing more magic there.
Guys, it's okay to write a question in our group, and I will ask Florina later. We just need to move on because we have so many things to cover. So I'm sorry that we'll have opportunity to ask all the questions that we want. But I promise you, you can write. Florina not going to any place. She's actually staying here till tomorrow. So we will able to ask her questions as much as we want. Just write it to me, like on Slack or in our Slack, and we'll ask Florina later or provide her.
But we can still do this, like after every main concept, like now after live data, we can take some questions and then we can see that. So, okay, live data. So live data in the end is actually just a data holder. So this means that if I have, let's say, the live data of a user, it will just hold that user information, and then other objects can set that data on the live data. And then objects that have a life cycle, that are a lifecycle owner, can observe this live data. So, and then can react on those changes. So in this case, for example, maybe I want to display that information of the user on the screen. But then, when the activity is on pause or on destroy, well, the live data is considered to be inactive. So this means that the events are not propagated to the UI. But then once we're restoring the application, so once it's on resume or on started, then the live data is considered active. So then every change will be reflected. Well, in order to set actually that data on the live data, you will need to work with a mutable live data. So mutable live data is just a type of live data that exposes two methods, post value and set value. So you would call post value when you want to set a value from a background thread, and then set value when you want to set a value from the main thread. If you're using Kotlin, I strongly recommend using a backing field for this, because and then just exposing a live data to the outside world, because like this you ensure, let's say, the immutability of the class, more or less immutability. You ensure that no one else from the outside can change that value. Okay, so then the live data, I was saying that it can be observed in the context of a lifecycle owner, so that this there is a lifecycle owner. And then in the onChange method, we can just update the UI. In this case, for example, we're getting the username and the user email and then just setting them on some text field. So under the hood, actually live data just holds a list of observers. And then every time you're setting the value in the live data, either by calling set or post value, then all of those observers will be notified of that new data. So that's pretty much the magic behind it. Okay. But apart from the live data, we also provided a set of transformations or methods. So let's say that we want to show a toast every time we get a string. So let's say that we have a network error, or when a user is deleted, or when a user is updated, we want to show that, hey, we have an error, or user X was updated, and so on. So in order to do this, it means that we need to expose a live data of a string with the display message, and that live data would actually come from 3 different sources. So network error, user deleted, user updated, all of these would be sources of events. So more precisely, it means that we would have, let's say, a live data that tells us the network error, and then another live data that tells us that a specific user was updated. So what we need to do in order to combine or to use data from multiple sources is to use a mediator live data. So the mediator live data allows us to set a live data as a source, and then it allows us to define what should happen when that live data has a new value. In our case, what we want to do is to set another value in the display message. So for example, here, we're saying that, So for example, here we're saying that whenever we want our user was updated, then in the display message, so the one based on which we're showing the toast, we're posting a new value, which is just a string constructed based on the username. And then when we have a network error, well, we're just posting another value with the error message. Okay, but let's complicate the situation. Let's say that we want to display a list of elements. So more precisely, we want to display a live data of a list of strings. And the data will come from a repository, and more precisely, we would have a search box there on the top. That would allow us to get the users with a specific name. So this means that whenever we're entering something in that edit text, we're triggering get users with name on the repository, and then that repository will emit some data. More precisely, that data would be a live data of a list of users. And then somehow we will need to transform that list of users to a list of strings, and then populate the UI. Well, to do this, we can just work with a transformation map method. So here, we would have the user's result. So here we would have the user's result, which is that list that comes from the repository. And then every time that user's result is updated, well, then we just map that list of users to a list of strings. That's all. Okay, so this means that, let's say that we want to get the users with name Alice. Then our repository emits that live data of all the users that are called Alice. And then we're populating the UI. But then, we want to get the users with the name Bob. So this means that at this point, the repository emits a new live data that has the list of users with the name Bob. So right now, we end up with a UI that is actually observing 2 different live data. The one that has the result for Alice and the ones for Bob. So what I also ended up doing, and I've seen this happening, is you forget to unsubscribe. You forget to stop listening to a live data. So I ended up with a mix of data actually coming from both sources. So whenever I got some new, let's say, users with the name Alice, my UI was updated, although in my search field I was waiting only for users with the name Bob. So the reason, as I was saying, was because I wasn't unsubscribing, and I wasn't making sure that I'm only listening to one source of live data. Well, actually, in order to do this automatically, without having you to unsubscribe and subscribe again, we would work with switch map. So in the switch map, I'm just saying that based on my so the username result would actually be just a switch map of whatever query I have. So in my case would be the username of Alice or Bob. And then I would just trigger a search in the repository for that name. And then I know that every time repository.search is called, I have a new instance of the live data. So actually under the hood, this switch map just uses a mediator live data. And I hope you weren't saying that to me. So under the hood, the switch map just uses a mediator live data, and it does just add source and then remove source whenever something else is called. Yeah, so in our repository, I was saying that we're returning a live data. And then in our view model, for example, so the class that holds all of this logic, populated every time we're searching the user based on a different name. So this method, search user by name, would be something that's triggered from the UI. So every time our user added a new name, would say query set a new value. And every new value that is set on the query will trigger a new request to the repository. And then because we're using this transformation switch map, we don't need to add and remove and manually make sure that we're listening to the right source. Okay, but what if you want to do your own custom transformations? In the end, having just map and switch map might not offer everything you need. So one place where I needed this was making sure that I have distinct values. So more precisely, let's say that I'm setting a value on the live data, but then if the same value is set again, I want to make sure that that value is no longer propagated. And only once I'm setting a new value, only that one is propagated. So if you're familiar with RxJava, it's similar with distinct until changed. So how do we implement our own custom transformation? Well, I implemented a method that I called getDistinct that would just return a live data. And under the hood, I use the same approach that the transformations are using. So more precisely, I use a mediator live data, where I'm adding as a source my live data. Then I'm checking whether my live data was initialized or not, and I'm keeping the last object in memory. And then whenever that live data emits something, I'm checking, okay, am I initialized? If I'm not initialized, it means that it's the first time when I'm calling this. So now it's initialized, the last object is the new value from the live data, and then we're emitting it. But then if this is the second time when this was triggered, so for example, the first value of the live data was Alice, and then I called again with Alice, I'm checking, okay, is this the same object? In our case it was, so then if it was, then I'm not going to emit it again. But if the second emission is of Bob, for example, then we're posting the value to the distinct live data. So one example where I had to do this was actually with a sort of a false positives with root. I'm going to tell you more about this a bit later. Okay, one of the questions that again I got quite a lot is, okay, did we just create live data as a replacement for RxJava? Well, the thing is that there are a lot of differences between live data and RxJava. Well, first of all, live data is just a data holder. It doesn't have any terminal events as RxJava streams have. And it works in the context of a life cycle. So it only emits the values when the life cycle is, let's say, started. So if you just think about the observability of a value, yeah, you can say they're similar. But I think there are quite a lot of things that make them different. So more precisely, I don't see this as a live data versus RxJava, but rather I see it as live data and RxJava. So in order to do this, to have this interoperability between the two libraries, we created the live data reactive streams class. So more precisely, it allows us to transform from live data to RxJava and the other way around. So let's say that we want to create a live data from a publisher. So this means that whenever the lifecycle owner is active, so whenever we start observing a live data, only then, whenever the publisher emits something, it will be, the UI will be notified, or whoever observes the live data will be notified. But then once we start observing, so for example, when the live data becomes inactive, well, nothing happens. We're no longer notifying that my live data doesn't get that new value from the publisher, even if something changed there in the stream. So even if something changed, we don't get anything in the live data. So this means that the value that's being held by the live data is quite an old value. So actually, what does it mean practically? One place where I like to use live data and RxJava actually to combine them is in the view model. So this means that for the business logic I could use RxJava, but then I would use live data just to make this connection between the view model and the UI. So this means that when I'm rotating the device, even if we got something from from RxJava, then nothing gets to be set on the live data. So this means that when we are recreating the activity, you might end up with an old value. Okay, what if we want to do the other way around? So what if we want to create a publisher from a live data? Well, we would use a live data and a lifecycle for this. So this means that only when publisher.subscribe is called, only then the live data starts being observed. And then whenever we're setting something on the live data, it's going to be emitted or set on the publisher. And then once we call cancel, then we also stop observing. Before I go forward to the view model, let's see if we have any questions for the live data. Yes.
I've noticed that you only use Kotlin for the live data. Is it possible to use Java also?
Oh yeah, absolutely.
Okay.
Yeah. It started actually with Java when we developed it, but then well, we switched to Kotlin.
I've never used Kotlin.
The question was whether we can use live data also with Java, not just with Kotlin, because the slides are in Kotlin.
Yeah, because for right now I'm not comfortable with Java.
Yeah, definitely. And I don't know, I think more I wanted to make sure that you know that we also have interoperability with Kotlin, so you can use in general architecture components with both Java and Kotlin.
Yeah. Do you have any examples?
Yes, not on the slides though.
No.
But in general, when you're looking for examples on architecture components, check out our repo. So it's Android architecture components on the Google samples, and there we have examples for most of the things in both Java and Kotlin.
Thank you.
Here, you first.
When I'm working in a repository pattern, and I'm working with a retrofit, for example, which returns, it cannot return live data, so far as I know. So if I'm working with the same data source interface, I need to declare the return type of both the remote data source and the local data source. Local data source is like room or something, and the remote data source is a retrofit. So I need to be constant in the same, in both data sources. So retrofit only gives me flowable or single or whatever, right? So I need to follow the restrictions of retrofit. So I cannot work with live data when I'm working with retrofit.
Well, not by default, but in the end, what you're missing is just a layer that wraps RxJava to live data. So you could just use live data reactive streams if you want to convert that. But to be honest, because you're saying that you're using RxJava and you also seem quite confident or quite comfortable with it, I would suggest using streams. Just as if you're using RxJava, you're using it because it's so powerful and because you can nicely work with streams. Right. Stuff like, I don't know, combine latest, that's not something that you can easily do with live data. You can if you implement your own transformations, but it means that you need to, let's say, reinvent the wheel for live data when when RxJava already has it by default. So to be honest, in such a project, probably I would just keep RxJava up until the view model, and then from the view model on, I would do that change. Also because then chances are in your UI, you have only a limited number of sources that you're working with. So this means that you only have maybe a few streams of data. So you won't need to do all of those changes on the retrofit on all the calls that you have, but rather more locally, more only in the view model and only on the sources that come there, that get there.
Okay, thanks. Actually, my question connected maybe and similar, because maybe it would be great if, let's say, Google data companies will have some integration with RxJava in the way that, for example, compose lifecycle owner, lifecycle, and then it will be automatically displayed.
So, if we could have an integration between lifecycles and RxJava.
Yeah, it would be great. And
I know.
And also for room.
Don't go ahead of yourself. Let's get there. So in the end, what you want is a sort of RX life cycle, right? Well, the thing is that if you look at ownerships, it's about RxJava wanting to support lifecycle. So it's not necessarily Google that needs to support this, but rather it's RxJava or I don't know, the RxJava community that wants to create this kind of support. So the ownership would be on their side.
Sounds like a great commit to the Git repository of RxJava.
Yeah.
If I use in the repository from room with live data and retrofit with Rx, you suggest to use publisher to combine both to the view model?
So the live data reactive stream uses the publisher API because that's a sort of a, let's say the main streams API. So if I'm not mistaken, publisher comes from Java streams, whereas observer and flowable and so on come from RxJava package, which uses this Java streams. So that's why we chose publisher, not specifically completable or flowable or something, because that's a sort of the base class for all of them. So you should be able to easily cast to publisher. And there was one question.
I'm using mediator live data a lot, not only for listening to multiple live data events, but to process logic before the UI is updated. Do you think it's right or
So the question was, you were using mediator live data for UI logic, and
before I get to the UI, I want to do some logic.
Yeah, so for the business logic maybe.
Yeah.
Yeah, and whether this is correct or not. I would say yes. I mean, in the end, that's why we're exposing live data also from room, which I'm telling too much. So you can use it also from there, from the data layer. So yeah, you could do that, of course. Let's take one last question and then we continue to view models.
Do you plan to expand the transformation class to match RxJava?
No. That's what I'm saying, that it's not about us creating, if we're planning to expand the list of transformations to match RxJava, I don't think you can actually match RxJava. I mean, it's a library that's been developed for so long and its role is different. We're not providing necessarily streams of data, it's a data holder. If you want to provide those kind of transformations, of course, it's good to share with the community the things that you're developing.
I saw in that following the question from Alexander, I saw that someone already did Kotlin extensions to the live data in order to match all things that you can do with our RxJava.
All?
Not some of them. Some of them. So are you going to support that? We're going to provide additional support for Kotlin extensions in order to make the live data capabilities much larger?
I think that's two different things. Because I don't think it matters if it's Kotlin or Java. It's about extending the live data capabilities. And then supporting Kotlin extensions, that's the second question. As I was saying, at least so far, I don't think there are any plans for adding more transformations. I don't remember seeing any bugs about it or any feature requests. In general, if you find any bugs or if you have any feature requests, please create an issue on the official issue tracker. Of course, tell me also. But that's, let's say, the most direct way of getting to the engineering team and getting, maybe even more reasons on why this or that can or cannot be implemented. And then in terms of Kotlin extensions, well, we've been launching the Android KTX, and now I don't remember if for live data, no, actually I think for live data reactive streams we even have something, some KTX, but was some quite small API improvement.
I saw the commit on the pull request. One of the pull requests was actually to make through the Kotlin extensions to make the live data API much richer and in order to match the RX Java capabilities.
I think that's just I think you could rather see that as a Kotlin extensions on a third-party library. Okay. View models. Okay, so I was giving this example where, based on the UI, you would call some data, you would call the repository, and you would do some work with the data. Well, the class where you would do this would be the view model. So the role of the view model is to get the user actions. So in our case, the fact that the user entered a new name, and then the UI would observe live data objects from the view model. So the view model can either be a view model or an Android view model. The difference between them is that the Android view model takes the application as a constructor, whereas if you want to create a view model, then you would also need to provide your own view model factory. And to be honest, this is something that I tend to use the most, the view model, and then with my own view model factory. Because like this, it means that I'm controlling the dependencies of the view model, and I can make sure that the view model is unit testable. Okay, let's look a bit at the life cycle of, or the life of a view model compared to the life of an activity. So we're usually creating the view model when the activity is created. But then that view model is alive until the application is, or sorry, until the activity is completely finished. So only then the onClear method on the view model is called. So actually this, So this means that the view model survives configuration changes because it survives those onPause, onResume calls. But then it won't survive stuff like pressing back or killing the app from recents, or when the fragment kills the framework kills the app. So actually what's going on under the hood, we're just using a fragment. Well, the logic is more complex than just, but we're using a fragment that holds that view model, so a retained fragment. So this means that this is how it survives configuration changes. But because that view model is connected to the life of an activity or a fragment, then once that fragment or activity are completely destroyed, then that view model can't survive. So another question that I keep on getting is, what's the difference between the guide to app architecture and the MVVM pattern? So maybe I should have said here a few more things about the guide to app architecture. So the guide to app architecture suggests having this kind of a pattern with a repository, a view model, and the UI, where the repository is the main source of truth. And then the view model exposes data, via live data in our case, to be consumed by the UI. So, in the end, what's the difference? What are the similarities? Well, first of all, the thing is that both of these patterns promote the separation of concerns. Both of them are saying that, okay, this repository is the one that combines data from the network and from the persistence layer. Both of them are saying that the view model is a holder for the UI data, that the view model exposes data to the UI, and most importantly, that the view model does not have a reference to the UI, unlike the MVP pattern. And then the role of the UI in both of these is to just display the data. So also, in both of them, we're driving the UI from a specific model. So here the repository is a single source of truth, and then based on it, the UI gets updated. And then, in general, for both of them, the way we're saving state is also quite similar. So the view model will be the one that saves the state for the UI to be, or keeps the data to be displayed. Whereas in the UI, on saved instance state, we would just keep, let's say, the minimum amount of information that is needed in order to restore that UI. And then in the repository, or more precisely, maybe in the database, we would keep the data that we want to persist even when the process is killed. So all these things tend to be quite similar. What are the differences? Well, the thing is that we don't really have a proper MVVM definition. So if you just if you just take 10 random GitHub projects that are saying that are showcases for MVVM, chances are you'll find 10 different interpretations of MVVM. We don't have one specific way to do it. So there's no, clear definition of what MVVM is in Android. So this is why we avoided saying that, hey, we're supporting MVVM, because developers don't really know what MVVM is. Is it what I implemented or what you implemented? So this is why we suggested doing this guide to app architecture, where we're providing general guidelines of let's say, making separate and clean and testable applications. So in the end, all we want to do with all of these libraries or all of these APIs that I've been talking about, it's about having things separate. That's why we have the lifecycle and the lifecycle owner. That's why we have the view model, because in the view model you should have the UI logic. The UI logic that, I know I also put it in the activity or in the fragment way too many times. But now that can be moved in the view model or in other layers also. And it can be tested. So in general, actually, when I'm writing code, then especially when I'm in a UI or in a framework class, like an activity or even a service, I'm thinking, okay, the code that I'm writing right now, can I unit test it? Does it have logic, and can I unit test it? If it has logic and I can't unit test it because I'm in the activity or in a service or in a fragment, then I should move it somewhere where I can unit test it. So in general, what both of these architectures, so MVVM and the guide to app architecture, are advocating is scalable and testable applications. So before we switch to room, let's see if we have any questions so far. Yeah.
When implementing custom views, so if you think of a view, if I go, like, I use the lifecycle owner, I use live data, and I use MVVM. So I want to take the custom view and actually observe live data. But to be able to do that, I need to implement the lifecycle owner, or I should get an instance of it from somewhere else. Maybe from the fragment that contains my view. So I was kind of wanted to know what's the best practice in doing that. So should my view implement lifecycle owner, or which is a little bit complicated, depends on the view I'm extending. And if not, should I take it from the, I don't know, activity or fragment that contains my custom view?
So the question was how to work with, or how to best implement custom views that want to observe live data. I would say it depends on the view that you want to implement. If you have a custom view that's always there, so for example, it's a custom view part of a fragment or an activity layout, I would say that you could use the lifecycle of the fragment or the activity. But if you have a view that's part of a recycler view, for example, then you can't really do that anymore. So this means that you're not really able, let's say, to use live data. What I'm hoping is that the paging library can solve some of the stuff about recycler view and about some of that, let's say, notification of the UI. But I would say that if it's a simple custom view that's not related to recycler view, you could use the lifecycle of whatever parent you have.
One more question, please. If you build an application...
I'm not going to give it to stickers, I'm sorry.
If you build an application that's got like a single activity with multiple fragments, and let's say okay, the activity has its own view model, and the fragments got their own view model, because maybe they're reusable in other parts of the application. If I got some, I don't know, web service call that I'm using in the fragment of the view model, like the fragments view model, I'm going to some web service, and I actually want to transfer some data that I've received over there to the activities view model. Does it go through the fragment, or can they communicate directly?
The question was, let's say that we have an activity and that has multiple fragments. activity and fragments have their own view model. And I think the key of what you asked is saying that the fragment is talking to a network, to the network.
The view model.
The view model is talking with the network layer.
We can even simplify it. Let's say we have some data in the view model and the fragments view model, and we want to transfer it to the activity.
So how do we transfer data between the fragment and the activity? Well, I think the role of that is of the repository. So the repository can be the class that's shared between fragments. So what I tend to do is to create repositories for every type of class. So I don't know, a repository for users, and then another repository for I don't know, GitHub repositories. So then this means that if I have some object that needs to be from the network, that needs to be shared, it means that the repository is the one that has that information. So if you're talking about navigation as in, do you want to pass it from one fragment to another or from fragment to the activity?
From the view model to the other view model.
Yeah, but to whom do they belong? To whom the view models belong to?
So one is the fragments view model,
and
the other one is the activities.
So probably what I would do is have like a reactive repository, and then, or if you're using clean architecture, a use case, that is shared between the two. And then both the fragment and the activity are observing the same instance of the object. So then even if someone sets it, then whoever observes it knows that that data has changed. Can we get one more question? Can we get someone else other than you asking questions?
I have any questions.
Do you have someone in the back? Yeah, there's someone in the back there. I see a hand waving. And you're not done running.
Guys, questions, don't be shy.
You said before the difference between use factory and injected with the Android view model. Can you give some more explanation on what is the right way and what is the difference between them?
So what's the difference between the view model and the Android view model? If I got the question.
Using the factory.
Yeah, so when you use the factory, then it means that you have control on creating the view model. So you can say that the view model, for example, is created based on a repository object. Whereas if you're using an Android view model, then by default the fragment or the framework, sorry, will create this for you based on the application class. So you would need in the Android view model to somehow get a reference to that repository class. So this means that you end up in an architecture where a class knows how to construct its dependencies. And that's the part that I personally am trying to avoid. I don't think a class should construct its dependencies, but rather the dependencies should be given to it at construction time.
Another question from the back, the brave ones.
You two are having too many questions. We have to get other people to ask.
Guys, from the back, questions? Ronen, question? I know you have struggled a lot with the live data to get after all mess that I left. So maybe I have a question. If I want to to have only unit tests, and actually integration tests with an Android view model, so basically I need a context. So what's the proper way of getting rid of the Android dependencies in the tricky question.
I think the application can be mocked, if I'm not mistaken, if you want to unit test it. But to be honest, I tend to prefer using the view model with parameters. But for integration tests, well, if it's integration test, it means that what do you want to is it like espresso test, or you want to test the UI? And
no, I don't want to test the UI. So I want to test the part of the view model, like the whole that all parts of view model were created correctly. So, for example, the initiation of the live data and other stuff, right? So this is all these parts if I'm not using Android dependency, I can test with easily with the JUnit test, right? At the moment when I'm adding Android view model, so there's an Android dependency, so I need to use integration test, and then it's become the framework itself needs to be initiated in order to run the test. So the question, what's the better way of get rid of it? Or it's by using view model and passing application context through the view model factory, or maybe to extending the class in the intermediate way and then
to be honest, if possible, I would try not to pass the context at all. I was that if we have a life cycle for a view, then whether we can have a view model associated to it.
Yes.
For the view only. So with if you think about the default view model implementation, I would say that that definitely wouldn't be a good idea, because if you have 10 views, you would end up with 10 fragments that would keep that. So we would need a different way to create those view models.
Yeah, so why are you working on lifecycle for view?
For the lifecycle, in order to expose the fragment views lifecycle. Okay.
You just talked about the factory methods for view models. So if I'm using, for example, dependency injection with Dagger or any other framework, I want to give it like an repository, and I want to give it an argument. Like, I don't know, an integer or something. Is there any solution for this?
I think that's more of a Dagger question, and if I'm not mistaken, in the GitHub browser sample that we have on Android Architecture Components global sample, I think that uses that. I know it opens a detailed view, and I think it also opens it based on some parameter. So I would say check that out. Okay, cool. Room. Room's my favorite topic. So, well, it's my favorite topic because for a long time, whenever I was thinking about databases, I had the similar face like that. I have to admit I was really avoiding it. And I was avoiding it because there was so much boilerplate that I needed to write, all of that cursor, get in, cursor, get string, and so on. And then, because it was difficult to implement migrations, whenever I was adding a column or updating a column or adding a table to my database, it felt like, you know, I'm diffusing a bomb, and then I need to make sure what I'm changing there, because the application might explode in the hands of my users. And that was also because, well, it was quite difficult to test the database, and therefore also difficult to test the migrations. And then also, whenever I had something to change, well, to be honest, I'm lazy, I copy-paste a lot, so I ended up requesting data from fields that weren't there or from columns that weren't there. And all of those things were things that I can only find out about when I was running my applications and I was saying that, hey, some field is not there. So in general, it was kind of difficult to test and to quickly get feedback on that. And then one thing that I did, and I would almost say let's stop the live stream when I'm telling you this, but I trust you and I trust that this won't get out of this room. Well, I was even doing database operations on the main thread. Okay, so what's the problem with this? Well, the thing is that when you're doing a database operation, chances are that will take quite a long time. And we only have 16 milliseconds for a frame to be drawn. So this means that you can easily end up skipping frames, just because you're doing database operations on the main thread. So this is why we have Room. Its role is to, well, solve all of these problems. And apart from this, to give us that object mapping so we avoid all of that boilerplate, to give us compile time check queries, so we avoid having to run the application in order to find out that we did a bad copy-paste, to ease the migration implementation and so on. But let's go more into detail. So in general, actually in this talk, what I want to do, or on this part of the talk, what I want to do is go quickly over what Room is and what are its main components. But I want to make sure that I'm touching on some points on the implementation, on the inner implementation of Room that can have side effects on the way you're writing code. Okay, so let's go over the main components, entity level and database. So let's say that we have a data class, so a class that's a repository that has an ID and a name. And then we want to have a table in the database corresponding to this class. So more precisely, we want every row in our table to be an instance of this class. This means that every member should be actually a column. So in order to do this, we would just work with the entity annotation. So more precisely, we would annotate our class with entity. We can give it a table name, but it's not mandatory. If you're not giving it a table name, then it will just use the name of the class. And then we need to set a primary key. And if we want, we can set a column info. So here, for example, I'm saying that well, the column ID will be called ID. But then for the name, I'm not providing any other name. So for example, I could have said here repo name as a column name. So this means that we're defining the table, the primary key, the columns, and then Room ends up taking care of all the defining and creating the table for us at the right time. So more precisely, when you're installing the application for the first time, Room will only create the table when it's being accessed for the first time. Actually, that's how SQLite works, so it's no magic from Room. Because Room, in the end, it's just a wrapper over SQLite. I think that I should have started with that. Okay. One thing to notice is that, for example, in this column, the name is a non-null object. So this means that if we're trying to add a repo where the name is null, well, Room will just throw an SQLite constraint exception. Because by adding this kind of information that the field is non-null, then Room automatically sets that constraint to the table. So when it generates the query for creating the table, it will automatically say that that column is non-null. But then, once we define the column to be nullable, for example, in Kotlin adding the question mark, then it means that when we want to add a repo where the name is null, everything is okay. If you're using Java, then you would use the @null annotation to define non-nullable columns. Okay, so what does this mean? It means that by just adding a question mark or by just adding an annotation, you are changing the table scheme. Because Room has this connection between the field and how the table is created. It will automatically know that something changed, that that constraint changed. So this means that by just adding the @null annotation, for example, you'll end up having to implement a migration. So be careful when you're doing this.
It will warn me during compile time?
Sorry?
It will warn me during compile time?
It won't warn you at compile time because it would only see that at runtime. Because at runtime, you I do want to go into migrations today, but maybe I should a little bit.
Our primary key could be nullable.
Wait, 1 second. First question. So how does Room know about this? So when you're so under the hood, Room actually uses like a hash map, a key for how the schema is. So whenever you're starting the application, then it will try to recompute that hash map, that hash value, and then it will check what's the value of that hash compared to what it had before. So it will see that, hey, something changed. And then it will also tell you that something changed and you didn't change the version number. So then also depending on what kind of flag you're setting when you're constructing the table, or though I'm really going ahead of myself now, you're able to either create or define migrations or not. So You can say that you don't care about migrations, that whenever you're changing the version number and you're not providing a migration, then you're okay with the database being wiped out. Or you're saying that, no, I want to implement the migrations. So in the end, that's how it checks it, and it's only at runtime. The question was, there was a note here that indeed the primary key is nullable. Yeah, indeed, that's a mistake. In general, because this is an int, so this is a primitive. Primitives are non-null by default when you're creating a primary key like this. But in general, primary keys can't be null. So if you're trying to do this, I think it's a compile. We put it as a compile time or runtime issue. Remember, but definitely you will know whether you're trying to have an object as a primary key, and then it can be null. Okay. Oh, one other thing that I wanted to say related to the column names. So here, the ID has a column info, but then the name doesn't. I would say that you should always use column info. And here's why. In the end, chances are that you will work with these objects. So you would work with the repo class in other classes. So what if you realize that you said the name wrong? Let's say that repo name isn't really relevant because you will have some other name there, and you wanted actually to name this variable as repository name. Well, you won't be able to do this quick variable or quick member rename because, as I was saying, Vroom is using the member name or the field name as a column name. So this means that by changing the member, you're also needing to provide the migration. So that's why I'm saying that it's great if you always use column info. It's not that much to write. So, and I think it's better afterwards, long term. Okay, so we define our table. So we want to work now with the table. So to do queries like select, insert, update, and delete items. So in order to work with it, we would define a DAO, so data access objects. So in the DAOs, we can we have several elements like we have several annotations like query, insert, update, delete, and raw query. But with all of these. Actually, Vroom is the one that's doing all the heavy lifting for us. So Vroom is the one that's doing the object mapping. All we need to say is that we're inserting a repo object, and it will know what that is and how to translate that in all the ugly SQLite database objects that we used to use before. So what I think is interesting and important is the fact that Vroom supports inheritance. So this means that you can define a base DAO, and then there you can define insert, update, and delete. And then every DAO that you have can extend that base DAO. And then in each proper DAO, you would define the queries. So you can't put the queries in the interface because, well, Vroom wouldn't really know how to interpret that. So wouldn't know, okay, you're putting a select star from T, what's that T? So it won't be able to actually compile that query and give you all of that compile time check queries that it has. So all of that benefit. So this means that only insert, update, and delete can be put into a base interface. Okay, so again, what I think is important to remember is that you don't need to return the entire table from when you're doing a query. You can just return a string, for example. Or you can just return a smaller object that you define. So you can return another data class that only gets a subset of that data. Then we can, or in the last few versions of Vroom, we've also added support for optionals. So let's say that we want to get, let's say, repos based on a specific ID. What happens when that ID, when that item doesn't exist? By default, the value that you would get is null. But we've got a lot of requests for both Guava optionals and also Java util optionals. So we've added that support. You need to add the specific libraries for it. So this means that when you're trying to do a query on an object that doesn't exist, then you will just get optional.absent or empty, depending on which optional you're using. Okay, so now we define the entities, in this case repo, And then we actually didn't, yeah.
But if we import important, we don't get this optionally, right?
You do. So the question was
Why
if
we need the optional encodement?
Why not?
You mean why not just return a nullable? I think we're not supporting that. If I'm not mistaken, we're no, actually by default here. Well, in the case of lists, it will be an empty list. Okay. But if you're returning a repo, no, I think if you're returning a repo, it's indeed a nullable object. But if you're working from Java, yeah, you can return an optional. But you can return an optional even if you're working with Kotlin, if you really want optionals. But it wouldn't really make sense. Okay. So, creating the database. To create the database or to define the database, we would work with the database annotation. So here, we need to define what our entities are and what the version is. So, what's important is that really you should put there all the entities that you have. Because if you're only putting 2 out of the 3 entities that you're creating, well, Room won't know about the 3rd, and it will just create a table with those 2. It will just create a database with just those 2 tables. So make sure that in the list of entities you're adding all of them. Then you can define the DAOs, so how to work with the database. And then when you're creating it, when you're building the database, I recommend using or creating a singleton. You can just create a singleton as you would normally use, or if you're using Dagger, use an @singleton annotation. So the thing is that, in general, when you're working with SQLite databases, it's good to make sure that you only have one database open at one time. So you're not working with multiple database instances. So again, because Room is just a wrapper over SQLite, we should make sure that we're only using one instance of the Room database at a time. Okay, but let's see a bit more what's going on with queries. So we have insert, update, delete query, and I didn't really mention raw query, but I will. We'll start with insert, update, and delete because, well, under the hood they are pretty similar. So let's say that we're defining our interface for our class. This is an interface, right? What happens? What's the implementation of it? Well, this is something that Room generates for us. More precisely, it's going to be the name of your DAO underscore envelope, so it's easier to find it once your code compiles. So if you look under the hood, you see that it's using a Room database. Well, actually, this Room database is an instance of your application's database. And then you'll see that it implements the method that you define in the interface. So in our case, we are inserting a repository. So what I really want to show here is the fact that it does this begin transaction, set transaction successful, and end transaction for you. So it ensures that everything you're doing in your DAO is atomic. So this means that if you're inserting an array of repositories, then that insertion will be in bulk. It will just happen in one transaction. Okay, but what if you want to do multiple operations and you want those operations to be inside one transaction? Well, so for example, let's say that we want to add and remove a repository and we want this to happen atomic. Well, if we're in the DAO, all we need to do is work with or annotate the method with @transaction, and then Room will know and will know how to wrap this inside the begin start transaction. If I didn't put the example here, but if you want to do multiple table operations, then you won't be able to put that inside the DAO. So what to do in this case is to work with the run in transaction method from the Room database. So there, that's a method. It's not an annotation in this case, but in that method you can say that I want all of these methods to be triggered, all of these insert, updates, operations on the database to happen. Okay. So also again, what's similar between insert, update, and delete is the threading model. So more precisely, all of these are synchronous. So this means that they will be run on the same thread that you are calling them from. So this means that it's your responsibility to make sure that that's not the main thread. And actually, query can also be run synchronously. So what happens if you're running on the main thread? Well, you're getting a legal state exception. Because we're trying to avoid developers making the mistake I used to do and run database operations on the main thread. Okay, let's take a closer look at the query. So let's say that we want to select all the repos with a specific ID. So we can do this synchronously, get repo by ID, and then we get the repository. But we can do this also asynchronously, with maybe and single, or via observable queries, using live data and flowable. Okay, so what's going on with maybe and single? So let's say that we want to get the repository with ID 3. So this means that for both maybe and single, if that repository exists, it will just return it and the stream will complete successfully. But if you want to get the repository for an ID that doesn't exist, so for example 26, things happen differently between single and maybe. Single will throw on error with an empty result set exception. And then you decide how to handle it. And then maybe, well, it just completes. Okay, things are a bit different when you're using live data and flowable because these are observable queries. So this means that you're automatically notified whenever something changes in your database. So let's say that we want to get the repository with ID 3. So first we get 3 and Android KTX. But then we change the name of our Android KTX to Core KTX. So automatically, because we're using live data and flowable, we would get that value. So this means that whoever listens or observes the live data and the flowable will get that value. But then things are different when we're using live data and we're trying to get something that doesn't exist. So in our case, let's say that we want to get the repository with ID 26. Well, with the live data, we just get null, because live data supports null, and we know that the item doesn't exist. But then in the case of flowable, because this doesn't support, because flowable doesn't support null, well, we're not getting anything. So on next, on error, or on complete won't be triggered. So only then, once we're adding something on the, let's say, for ID 26, only then it will be triggered. So what's the solution? What if you actually want to be notified when there isn't anything to match the query? Well, there are several things that you can do. You can work with optionals. So for example, you can use optional, and then you would get optional empty, or you would work with a list. So then you would know that when the list is empty, it means that, well, there are no items in the database to satisfy your query. Okay, but here's the thing. You can also get false positives. So what does this mean? So let's say that we're getting the repository with ID 3, which is Android KTX. And then, in the same table, we are adding the repository with ID 26. Well, the thing is that our live data, or flowable, will emit again. And will emit again with the same value, with 3 and Android KTX. So it means that we actually get a false positive. We get that, hey, something has changed, but actually it didn't. So what's going on? Why is this happening? It's because SQLite only provides us a listener on something has changed on a table. So what actually Room does is when it gets a notification that something has changed in the table, all it does is trigger the same query again. So it won't keep in memory what was the last result that was emitted and do all of that logic for you. So what can you do? Well, you can implement a get repo by distinct. So this is a method that you can implement in an abstract, in your abstract DAO. And then if you're using a flowable, you can just return get repo by ID and a distinct content changed. And if you're using a live data, you would use the example that I used earlier, and I won't go over this again. So this means that there is a workaround this. Okay, so another difference between, well, synchronous queries and observable queries is the threading model. So both of these, independent if you're using live data or flowable, or maybe, only live data and flowable, will run on a background thread. So this means that you're guaranteed that the query that you're doing will be on a background thread. But the difference comes on the thread you're receiving the result. On the live data, it will be the main thread, because this is how live data works in general. That's the principle of live data, that the main work is being done on the background thread, but then the observers are notified on the main thread. And then on the flowable, well, you'll be notified on whatever scheduler you're observing to. I didn't add here, maybe I should have. It's different when you're working with maybe and the single, because there you have to provide both the observe on and subscribe on. Yeah, we had a discussion on whether we should provide these automatically or not, and it felt like the community wanted more to just give the freedom to the developers to provide both observe on and subscribe on. So we ended up in a debate on whether should we remove this functionality from the flowable or should we add this functionality to the maybe and the single. And so far we decided to just leave it like this. There is an issue on the official bug tracker, and feel free to start if you want to get updates on this. And the last query type that I didn't talk about is raw query. So one of the requests that we got from the community is to be able to define at runtime the query that we want to trigger. So in order to do this, we're exposing a method that takes as a parameter the support SQLite query. So this is the same support SQLite query I think that you would work with when you would implement your own SQLite database. But in the end, what Under the Hood Room will do for you, still as a benefit, is to do that object mapping between what object you're giving it to, in this case repo, because you're interested in repo, and all of that work with the database, with the cursors. Also, raw query supports observable queries. So, but the difference here is that you'll need to tell it what is the observed entity. Because your query, for example, can be a join or multiple tables, so it needs to know which table are you actually interested in observing. By default, if your query has is a join of multiple tables, then it will actually observe all of them. Okay. How about before I go.
If you already talk about the raw query and you mentioned the join operator, if I just create simple two entities, that one is a cell, one entity is a field inside the second entity. It's supposed to be a char. It's supposed to be anything that it will create the query automatically with the join and all the stuff. It will create, after all, two tables. If I have, for instance, entity of student and address, and address it's entity of
So would the address be a separate table?
Yeah, it should be, because it's a field inside the student.
Well, if it's a field inside the student, you can also embed it so that it doesn't necessarily need to be another table, but it can just be a set of columns in the student table.
It will flat the...
You can, well, it depends on how you want to define your database. So it depends on how you define your entities.
List of others.
Sorry?
A list of others. Then you have to
know. I think you're actually starting to ask me about what I'm going to talk about next with the database. I'm wondering if it's the same as database relations. Maybe let's question afterwards if it didn't clear it, because I was a bit confused. Okay, so I said we have a repo, but then we also have commits. So we only have a list of all the commits in the repository. So this means that actually a commit belongs to a repository. So this means that there is a connection between the primary key in the repo and the repo field inside the commit. So these are two entities. One thing that you would usually do with SQLite is add foreign keys. So foreign keys to make constraints between these two tables. Well, the same foreign key principles is something that Room also supports, only you would define them in the entity annotation. So here you would say that you would have a foreign key between repo and the commit class, and you would say what's the column inside the repo class and what's the column inside the commit class that are connected. And also, similar to what we have inside the SQLite database, you're able to define what should happen on delete and on update. And the default value, both for SQLite and also for Room, is Cascade. Okay, but what if you want to get the repositories with all the commits that were added to it? So this means that we want a class that has a repo and the associated list of commits. So, by default, what you could do is define two queries. One that gets you all the repos, and then another one that is able to get the commits for a specific repository. And then you would need to make sure that if you want to get all the repos with all the commits, that you're triggering both of these queries at the right time. But Room can help with this. So more precisely, you can embed a repo, and you can define a relation. So more precisely with the embed, Room will know that you just want all the fields from the repo class, or from the repo table, or the columns. And then with the relation annotation, you're saying that you also want all the associated columns, or sorry, all the associated data from the commit table, where the ID of the commit ID, sorry, of the repo ID is the same with the ID from the repo. Okay, and then what you will need to do inside your DAO is just to define a query with select star from repos, and then say that you want to return a list of repo with commits. So automatically, actually what Room will do under the hood for you is trigger those two queries that I was mentioning before that you will need to do manually for you. But it's actually no extra magic, it just triggers those queries. Does that answer your question? Yes. Okay, let's go to testing, because I think that's something that's extremely important and we never test enough. Okay, before we go to testing, we have two questions.
Yeah, I have one question about Room.
Okay.
Can you please give a couple of sentences regarding the migration? The pain of migration?
Can I go through migration a little bit after I'm going to testing?
No problem.
He was first.
If I have an object inside my object, and I save it, what happens to that object?
So if I have an object inside an object, so a repo has, so how are you defining them? Are those objects to different tables? Are they the same table?
No, the same table.
So what you can do is work with the embedded. So you, by default, when you're creating your entity, you can say that you have an embedded object inside it, and then Room will know to flatten it, and then to create an entity that has the fields that you define as members, but also all the members of the object that you define inside. Okay. Yes?
Can I use Room to access Android database? Let's say I want to use Room to access the contact list.
Okay, can we use Room to access the contact list?
Yes.
Okay, how to think about this in general? Don't think about Room, think about SQLite. Can you use SQLite to access the database, the context database?
Yes. The contact list, not the contact list. The user contact list.
Yeah, can you use SQLite to access the contact list?
Oh no, I'm using
content providers. You're using content providers, yes. Exactly. So then the answer for your question is no. Yeah. Encrypted Room? Encrypted database? We don't have that right now. I know that we have an issue on the official issue tracker. And I don't know if actually we're working on this. But I do know that we have an issue for encrypted Room. So I would say the best way to get updated on this is to start that issue.
Yeah, but so the question about the break.
About what?
Break. Break.
Let's finish room and then take a break.
Cool. So, guys, have you heard? Don't write me messages about the break. We're going to break. Finish the room and we're going to the break.
You are a lot of questions. Yes, you were the first one.
The insert and delete in room, they need to be asynchronous.
Insert and delete need to be
Asynchronous. They don't have live data. Nobody managed their background first.
Yeah, they're
What
synchronous.
If I don't use RxJava in my project, what is the recommended way to do this? Of course, I must do it in background.
How are you? So the question was, if I'm not using RxJava, then how I move the queries that by default are synchronous to a background thread. So I would ask you, how do you usually move things on a background thread in your application?
Java.
Then I would use RxJava.
But in a small project that I don't have the RxJava, and I don't want to add RxJava only for
Just for
this.
that. So what if I'm not using RxJava on maybe a smaller project?
Task is the
Yeah. No. How we are doing it on the sample projects, because they're exactly what you want. A simple project that just showcases that is to use executors. So more precisely, we're defining an I/O and then main thread executor. And then we tend to play around with these. So when we want to trigger something on the background thread, then we're using the I/O executor. And then if you want something, for example, to be run on the main thread, but then the result to be returned, if you want something to be triggered on the I/O thread and then the result to be run on the main thread, then we're using two executors, one for I/O and one for main thread. Actually, in the paging collab that I was hoping we also have time to do today, I'm using exactly this way. But you can also take a look at some of the projects that we have in the Android architecture components. Can I finish the room part and then get the questions and then allow the people that want a break to take a break? Okay.
People afraid to leave, to miss the important content, to go to the bathroom. And really, the situation is very hard.
Okay, you're sacrificing your bladder for architecture components. Okay. I promise I'll be sure with the testing. So, testing, please test. Whatever you're doing, please test. And because we want to support testing, then Room also allows you to do this. So, more precisely, to test your DAOs, you would implement your Android JUnit test. So, here you would define your database and you would define your DAO. You would create an in-memory database, and then in the before method, and then after you would close that database. So actually what's important to see here is that you could use an in-memory database. So this means that whatever you're putting inside this database, once the process dies, it won't be there anymore. This is not a new concept actually. This is something that SQLite also provides. The magic from SQLite is just to create a database without a name, and then automatically that would be an in-memory database. So what Room does is just build on top of the SQLite API that I think wasn't so popular because I didn't know about this at least. Okay, so how do we test it? So this means that you don't need to make sure that you're deleting everything at the end of every test. So that's the benefit of using an in-memory database. So how do we test it? To check that indeed you're able to insert a repository and then check that indeed that repository is there, you would insert it, and then you would just retrieve it. But the interesting thing actually is if you're using live data. Because live data, we know that everything happens on the background thread. So how do we test that? Well, how do we ensure that everything is synchronous? Well, to use this, we would use an instant task executor role. So actually what this does is, under the hood, it's exchanging the architecture components executor to an instant one. And to answer the question about the executors, actually this is what Android architecture components is using under the hood, just executors. If you look for Arch component executor, I think, in the project you'll find it and you'll see that it's not that complicated. Okay, so then you can get, when you're using live data, you're getting repo, get repo by ID. And then what I'm using here is a live data test-util method class to get the value. This is actually something that we define in our sample apps. So here, in the end, what we are doing is just we're observing the live data. We're giving it, I think, 2 seconds maximum to get the value. And then if we're not getting a value from it, we're just stopping observing. Or we stop observing until we get that value. So then the live data test-util get value will return the value that was in the database or not. So then we can just check whether the value was the expected one. If you're using the RxJava flowable, well, actually things are pretty similar. You would still use the same instant task executor. And then you would just test and assert. If you want to implement espresso tests, you would use a counting task executor rule. Okay, to go to migrations, I would say that these are your solutions or some of your main answers. I wrote 2 blog posts. One is about understanding migrations, and one is about testing migrations. I know I mentioned a little bit migrations when you were asking a question. I go a little bit more over several use cases on the migrations in those blog posts. And of course, you want to see the code. There's also in the Android architecture components, there's a repo that just covers migrations. So there I'm going through different versions of the database, and I'm showing, okay, what happens when you're just adding a column, or what happens when you want to rename a column, because renaming a column actually involves a more complex query. Yeah, in general, how you can handle it, and most specifically, how you can test it, because it's not that hard to test. Okay, let's take a break before we go to paging.
So guys, right now it's like 9.
Just to make sure we're all quite paying attention, I want to start with something that I wanted to finish. So I get a lot of questions about, okay, should I start using architecture components, and especially when things were in alpha, whether should we start using them? And I think what's important to remember is the problems that all of these components are solving, because they're all solving concrete problems. So if you have those problems, then only then I would say start moving to architecture components. I know that we all like to play around with new things, but I don't think it's right for, especially for when you're working in production, to just integrate something new just for the sake of playing around with things. I think the business value is more important. So make sure that you only start using architecture components when you actually feel the need. For example, if you don't have any problem with the database, then there's no need to integrate Room. But if you do have problems with testing it or with implementing migrations, then start using Room. Okay, let's go a little bit about paging. I promise it will be short. So the thing is that a lot of times we're working with large sets of data, but at one specific time we're only displaying small portions out of that data. So the consequences of this is that a lot of times, again, we're requesting data that's not needed. Maybe we're requesting entire data from a database or a big request from the network, although we don't really need that. Then a lot of times it's difficult to present fresh data to the user, and it's hard to keep small amounts of data in memory. I feel like I've lost the audio. Can you still hear me?
Yeah.
Cool. So in order to solve these problems, we have the paging library. So what I want to go over is the main components. Say a little bit what they do. I'll go a bit more in depth with what the data sources are. And I know right now we don't have time to do the workshop, but what I had also prepared was a code lab that, well, we can't do it right now, but you can also do it at home. And the examples or everything that I'm going to give as examples in the next few minutes is actually based on the same code as the workshop. So more precisely, what I want to show here is a list of GitHub repositories. So more precisely, I'm searching for repositories that contain the word Android. I'm working with the GitHub API, and I'm displaying that list of data. Okay, so in general, when you're working with a database or when you want to display a list of data, chances are your architecture looks something like this. So you will have a repository that is working with a database and a network, and then that repository would expose the live data of a list of repositories. So then whenever something changes on the data layer, that live data of a list of repos would emit again. Then you would have a view model that would work with that live data of a list of repositories, and then it would expose that to the UI. And then the UI would work with that list of repos, and then would have a recycle view adapter and would display all of those repositories in the UI. Well, actually, the paging library builds on top of this kind of architecture. So you'll see how step by step we're replacing each of these, let's say, components, or we're touching these layers, and we would work with paging library specific classes. So one of the main classes, the core, is a page list. Well, actually, a page list is nothing more than a collection. If you look at the class, I think it extends list or array list. So it's definitely just a collection. But apart from that, it's a collection that allows you to load data in pages. So in chunks of data that it calls pages. And it allows you to do this asynchronously. So this means that if this is our initial architecture, we would just replace that list of repo with a page list of repo. Then we would work with a page list adapter. So chances are in your application, you're either using a recycler view adapter, or if hopefully you already switched to the recycler view from 27.1.0 support library, you were already using a list adapter. So actually the main difference between these two is the fact that the list adapter in 27.1 is using also a repo comparator. So it allows you to easily define how to compare items in a list. And actually the page list adapter just builds on top of a list adapter. So is a list adapter, but has more properties and more logic under the hood. So let's see what that page list adapter is and what you would need to do. As I was saying, I think it's important to know what that repo comparator is. So it would be a diffutil item callback where you define how to compare two items. You would define when two items are the same and when two contents are the same. In our case, we can say that two items are the same when the name is the same, or an ID, or whatever you define. And then the contents are the same when the two items are equal. Okay, and then in your activity, then you would just observe your list of repositories coming from the view model, and then to the adapter you would just call submit list. Again, if you're already using the list adapter, then chances are that submit list part is already implemented. Okay, so this means now we've already changed our recycler view and we're already using a page list adapter. That under the hood will use the page list. Okay. Another component, main component, is a data source factory, and its role is actually to load snapshots of data into a page list. I won't go right now more into detail of the data source. I'm just telling you that this is a component that loads the snapshots of data, but I will go into it a bit more. But in order to construct a data source, you would work with a data source factory. So, more precisely, I was saying in our example that we would work with, let's say we have a remote data source. So we are only getting data from the network. So this means that our data source is the network. So in order to construct that data source, we would use a GitHub service and then a query, because we said we want to look for repositories that have a specific word. And then in the create method of the data source factory, we would just create a new instance of our data source based on these two parameters. Okay, so this means that right now, we already know that on the data layer, we are working with a data source factory. And then the data source factory creates a data source that can be either a database and or a network. Okay, but another component is the live page list builder. So practically this is the one that makes or builds the live data of a page list based on that data source. It is the one that makes the connection between the two. So the elements that you need to provide when you're building this is the data source factory and the page size. So in general, when you're selecting the page size, what's recommended is to use like a page size that is bigger than a screen. So you know what kind of items you need to display. So we recommend to be a bigger one. Because like this, you can avoid having, let's say, the UI flickering when new data is being loaded. Okay, but you can also use a configuration object. So the configuration object allows you to set multiple things. One is the setting the page size. Then setting an initial loading size. So this means that once the first set of data needs to be displayed on the UI, it needs to know what would be that initial size. By default, it's 3 times the page size, because it needs to make sure that you have enough data to be displayed on the screen when the user doesn't really scroll much. Then we can also set the prefetch distance. So this means that how many items until the end of the list, or at how many items until the end of the list should the paging library request a new set of data or a new chunk of data. And by default, this is the page size. Then we can also say whether we should enable placeholders or not. And by default, this value is true. So what do these placeholders mean? So let's say that we have a page list that loads items. So these placeholders just are just items that are not. So actually this is the way the paging library is telling you that I'm in the process of loading something. So let's say that if you're using network as your main data source, it will know what's the page size, so it knows that, okay, now I need to load the next 20 items. And then those 20 items, until they are retrieved from the network, they will be null. So then here you can display, I don't know, the null placeholders that you display in your application. But this is not the place where you would display a progress spinner. If you want to display a progress spinner, then placeholders are not the thing to use. Yeah?
If, for example, I ask for 20 rows and I get only 10, he show me 20 placeholder and you know how to cut them to 10?
I think I don't know, actually. I don't, what I'm expecting right now is actually that it might show the null, but I haven't tried it. I have to admit I wasn't in the situation, but it's a good question. Okay, so getting back to our configuration. Okay, so then this is how you create the configuration when you're using a live data page list. But we know that live data is not something that everyone wants to use. So that's why we also provided an API to support RxJava with the paging library. So more precisely, you can either return an observable by calling Rx page list builder, build observable, or a flowable by calling on the same Rx page list builder, build flowable. But then on the build flowable, you would also need to set what's the back pressure strategy. Okay, how about the schedulers? Well, by default, the fetch scheduler is the architecture components IO thread executor. So actually, this is the same one that's being used for room, or the same one that's being used when you're working with flowables or with live data. But you can also set your own scheduler. And you can also set the notify scheduler. And again, by default, this is the main thread. But if you want to be notified on a different thread, you can set it. Okay, so now we've actually ended up changing our architecture quite a lot. Because now the repository is the one that's working with the live page list builder. That when we're building based on a data source factory, it creates a live data page list. And then that page list is afterwards used by the UI by the page list adapter. And I promised to talk about the data source. So let's say that we have 3 main cases. One, the data source is the database. One is the network. and we said when we have a database and network. Okay, first case when the data source is the database. If the database is a room database, well, you're lucky because room is integrated with the paging library, and it automatically creates a data source factory for you. So all you need to do is in the DAO to define that an abstract method that returns a data source factory. Under the hood, room will know how to create this data source factory. Okay, so things are pretty simple. That's all you need to do. And then when you're working with the DAO or when you're building your live data page list builder, you just need to get a reference to this method from the DAO. That's all. Okay, what if we're working with network? So with the network, we'll again have several cases. The first one is when we request data based on a key. So let's say that we're working with the GitHub service again, and then what we want to do is to get a specific commit based on a key. So this means that we would need to define how to load the initial list of data. So here we would just call get commits based on the key and the requested load size from the parameters. What I omitted here is the fact that you will also need to call the callback to tell it that now you've loaded some data. Similarly, when you're calling load after, or when you're implementing load after, you would know how to call your service and get the commits based on that specific key that you're defining. And then paging also supports scrolling up and scrolling down. So when you're scrolling down, it would need to load before, so you would need to implement this kind of a method. But then another case when working with the network as a data source is requesting data based on a page. So for example, the GitHub API exposes this kind of API. So you will still work with the GitHub service, but this time you would implement a page keyed data source. And the API provided by the page keyed data source looks pretty similar to the one that we've seen at the item keyed data source. So we'd still have a load initial, but here, instead of loading data based on the key, you would load it based on the initial page. And then when you're loading after, you would again do the request to the backend based on the page. And again, what I omitted here to call the callback and tell the callback that you were able to load the items. And similar, you would use load before. Okay, so now we went over the data source as being the network. So let's see what happens overall. So I said that the first thing that we're doing is we're calling live page list builder build. Then under the hood, the live page list builder calls create on the data source factory, and then this data source factory creates a new instance of the data source. Then, based on this information plus the configuration, the live page list builder will create the page list, and the page list will be the one that will call load initial on the data source. The page list gets to be populated. The page list builder creates the live data of a page list. Then this information, the live data of a page list goes to the view model, then to the UI, to the page list adapter where we're setting the page list, and then the UI gets to be updated. But then once we're scrolling and we get to the end of the list, then we need to request more. So more precisely, we need to call, automatically the page list will call load after on your data source. So this is, in general, all the orangey lines are something that the paging library calls automatically. So the load after implementation will be triggered, and then the data source will load more items, and then those items are put inside the page list, and the page list will now have the data that it needs to display. Okay, things are more interested and I think more real world when we're working with a database that's backed by the network. So here we would still work with a DAO where we're defining the data source factory, because what we want is to have the database as being the source of truth for the UI. So this means that apart from, so the data from the data source will be the one that gets to be observed by the UI. But apart from this, we also need to define a boundary callback, because now we need to somehow tell the paging when we got to the end of the list. So in the boundary callback, so when we need to tell the paging library when we got to the end of the list and what to do when we got to the end of the list. So that's why in the boundary callback we're working with both a GitHub service, so we can make network requests, but also with the database, so we can save those responses from the network inside the database. Okay, so the boundary callback gives us several methods. One is when 0 items were loaded. So this means that, let's say that we're in the case where it's the first time when we're launching the application, there's nothing in the database, therefore on 0 items loaded is called. So this is the point when we're requesting and then we're saving some data. But then when the last item in the database was loaded, or when the first item, if you're scrolling up, was loaded, we're actually doing the same thing. So if we just look at the on item at end loaded, this is the case when we're loading data from the database, we've scrolled, and we got to the end of that data that's available in the database. Because, for example, you can say that from the network you're requesting 500 items, but then from the database your page size is only 30 items. So this means that on item at end loaded would only be triggered when we reach the entire data set that we have in the database. Okay, how do we use this memory callback? Well, we would set it to the live page list builder. Without this, it won't work. Trust me, I tried and wasted half an hour. Okay, so overall, let's see exactly what's happening with also under the hood. Let's see the big picture. Okay, so we said that we have actually a data source, and the main source of truth is the database. But then the data source will work with a boundary callback, and the boundary callback will do these triggers to the network and then set the data in the database. Okay, so the first thing that we do, we call live page list builder.build, and that's the one that triggers in motion everything. So the live page list builder calls create on the data source factory, which creates a new instance of the data source. Then, based on it, we're creating a live page list builder. We're also setting the boundary callback, so it means that we're creating a new instance of the boundary callback when we're doing that set boundary callback on the live page list builder. And then based on both of these elements, we're creating the page list. Because actually, the page list inside has a reference to the data source and a reference to the boundary callback. Because the page list is the one that works directly with each of them, telling or requesting more data or informing the boundary callback that it's out of data. Okay, so then the page list is triggering load initial. But actually, and then load initial is, well, the page list also tells the boundary callback that 0 items were loaded. So then the boundary callback requests the data from the network. Then these actually happen in the same time. So right now in the page list we don't have anything. So these on 0 items loaded and the request of the data happen in the same time with our empty page list getting to the UI. So two things happen. Our page list adapter gets to the UI, and then the network requests the data and saves it. So the first thing that we end up seeing in the UI is an empty page list. Nothing to display. But here's why let's say the data source factor. Because once we save the data inside the database,
I love survival.
the
want to thank you from the bottom of my heart.
the data source represents the state of data. So this means that at this point, the data source factory has to create a new instance of the data source. So if that method create that we implemented on the data source factory gets to be triggered again. So right now, this data source ends up being used by the page list. And right now, we have a page list that already has items. So a data source ends up being invalidated whenever we are doing any operation like delete or update or insert. on, in our case, on the database. Okay, so now our page list has items, and then our live data emits again. This time with this page list that has items, and then this one gets to the adapter, and then now we actually have items in the UI. Now when we're scrolling again, and we get to the end of the list, then we again call load after on the data source that does on item at end loaded, because this time we know we reached at the end of the list. Then the boundary callback triggers the request to the network, and then we're saving the data in the data source. And again, actually at this point, the data source, because we're updating it, ends up being invalidated, and then it will trigger again a new data source being created, this time with a bigger list. So again, as I was saying, if the data source or the size of the list that you're loading from the network is smaller than what the page size is, it means that this load after or these requests to the network will happen less frequent. So it depends on how much your users calls. Okay, my plan originally was actually to go more in depth in this once we're doing the code lab, because the code lab actually goes through all of these steps and shows you more how things happen with the paging library. So I would say check out the code lab at home. And this
we will share the link.
Hmm?
We will share the link.
Okay.
I'm sharing it right now.
And actually, this is all I wanted to say in an hour and a half that ended up being longer than an hour and a half. Can I get some questions first before we end about paging?
Yes. After the initial loading of the database from a network source, how can I make sure that when the user scrolls, the app doesn't get stuck and thinking about loading other stuff from the network? So it would be a seamless environment for the user, like user experience could be seamless. So the user scrolls and it doesn't see something like it gets stuck, but the UI thread doesn't get stuck. It gets stuck because it loads something from the network.
So the UI, so the question was how to make things as seamless as possible for the user and make sure that the UI doesn't get stuck when things are loaded from the network. Well, the thing with the paging library, because it's using under the hood live data a lot, is that it defers all of these network or all of this work to the background thread. So, for example, if you're using room, automatically things will be triggered on the background thread, all the getters. So a lot of the logic, a lot of the diffs between items in the recycler view, those are automatically done on the background thread. So chances are you might need to provide maybe a progress dialog or like a spinner or something, but it depends on where you're getting your data from. I saw that if you're just using the database, things are pretty fast. If you're using the network, chances are you will need to provide something like a spinner maybe that tells your user that you're loading something.
So basically it will depend on the speed of the network that the user has, like if it's 3G or 4G or whatever.
Yeah, so the network request part would still be the usual network request that you do. In the end, the paging library all it does is tell you that I'm out of data. Do something with me. Tell me, give me more data from somewhere. Yeah.
Can paging library load data from a content provider?
Okay, can the paging library load data from a content provider? Well, the thing is that you define the data source. My examples here were the database and the network, but in the end, you can put as a data source whatever you want. You can put it as a content provider, you can put a file, you can put hopefully not shared preferences, but it can even be shared preferences. So this means that as long as you know how your data looks like and you know what kind of data source type you want to do, like item keyed or paged data source, then you just implement your load after and load before, and you define where to get this from, like from a cursor adapter or from a file. You had a question?
What if I only need to present real-time data? So do I really need to have a database, or can I just not have a database and just use live data from the network, would that be a bad practice?
Yeah. So the question was, what if I just have real-time data? So what I was showing here with the network, I think that's the case that you want to cover, right? You just want to show data from the network.
Yeah.
That's all. So then what you need to use is either a page key data source or an item key data source or a positional data source. So in the end, you would define your own data source. What you wouldn't need anymore is the boundary callback, because this data source load after would be called whenever you're at the end of the list.
And another question. Thanks. You mentioned that some things are in alpha. So which of the architecture?
No, so what I meant in alpha is earlier was like the navigation and the work manager. And actually I think the RX page list, so if you want to support RX Java, then we have a separate artifact for that. And that one, from what I know, is in alpha. But then everything I talked about today, like room, lifecycle, paging, are already 1.0. So paging was released as 1.0 at I/O. Yeah, check out if you're using RX Java, check out the RX Java one, because I felt like we didn't get enough feedback from this. So in general, so I can end it, I think one of the reasons why I think architecture components, or at least the ones that I've been talking about today, ended up in quite a solid state, covering quite a lot of use cases, actually because of you, because of the community. We've got a lot of bugs or a lot of issues and feature requests when all of these components were in alpha, and developers, or you, really shaped the libraries. So now we already have navigation and work manager in alpha, so I would say check those out and then give us feedback. Not necessarily start using them, but check them out. And I think I'm being censored and I'm being told to shut up.
So everyone, please, big applause for Florina!
Thank you for having me.
In the name of everyone in this room and in
the last survivals.
In our community, we want to thank you from the bottom of my heart and everyone else's that you came for us. And it was very inspiring. Thank you very much.
Thank you for having me.